In homework 1.3, there are 4 different problem situations, and this is a weird homework to try to help you with because each of the situations is completely different. I'm going to pick number 3 on the back, and I'm going to walk you through kind of what the process should be to get this correct. The very first thing you should do is make sure you read the problem and understand it very well. You want to have a model in your head of what's happening. So the situation is Mr. Woodward has a bag of 300 Jolly Ranchers. So you should be picturing a bag of Jolly Ranchers. Students try to guess how many are in the bag. So there's a bag of 300 and kids are guessing. Maybe they guess like 5,000 or whatever. Mr. Woodward records how far off each guess was. So what's going to be recorded is how far away from the right answer each guess was. The student who is closest will get a candy. Fill out the rest of the table and then determine what type of function can model this situation. So let's figure out what's already filled into this table and make sure we understand what is going on. If you just start filling in numbers, as some students have done in the past years, like I've seen kids try to fill in numbers to make this match up with the 50, they get it wrong almost every time. So this says if a student guesses 150, how far off they are is 150. Let's see if we can make sense of that. Well, the bag has 300 Jolly Ranchers in it. So if somebody guesses 150, they were 150 off from the right answer of 300. So if they guess 200, how far off are they from the right answer of 300 Jolly Ranchers? Well, they're only 100 off. If they guess 250, the right answer was 300, so the amount off they are is 50. If they guessed 300, they were exactly correct, so they were 0 off. If they guessed 350, they are 50 off. If they guess 400, they are 100 off. If they guess 450, that's 150 away from the correct answer. If they guess 500, they're 200 away, and 550 makes them 250 away. So now that I have a table, I can use it and use my skills to try to see what type of function it is. I notice that as this goes down by 50, the x values are changing by 50 each time, so there's a constant rate in the x. It's going up by 50. 50, 50, 50, 50. So in the y, it goes down by 50, then down by 50 again, then down by 50 again. There's a constant rate of change, so you should immediately be thinking this looks linear or absolute value. And what we'll notice is it goes down, and then at 0, it starts going back up again. So because there are 2 different constant rates of change, one that was negative and then one was positive, it went down and then back up by the same constant rate, this is an absolute value function. Because there are 2 constant rates of changes, or I'll just say that there are 2 constant rates of change. One going down, one going up. Now I'm supposed to create a graph of this. The first thing I need to do is make sure my labels are correct. The x values are the guesses. The y values are how far off students were. I need to be able to fit my x to at least 550. So that makes me think maybe I should count by 50s here. I would need 11 spaces to make that work. Let's see if that will fit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, that's going to work. So I can count by 50s here. 50, 100. I'm going to run out of space here, so this is 150, but I'm not going to write it. 200, 300, 400, 500, 600. Notice that each unit is counting by the same amount, even though I only wrote every other number. The y values, I need to get up to at least 250. So I could count by hundreds, I could count by 50s, I could probably even count by 20s, but since I counted by 50s on the x, I think I'll count by 50s on the y as well. So 50, 100, 150, 200, 250, 300, and that's higher than I need to go, so I'll do one more. Now, you should be noticing that my graph is not labeled well right now because I've labeled the x-axis, but not the y-axis. The y-axis is how far off each student was. So I'm going to I'm going to fill in my table now. If a student guessed 150, they were 150 off. So the input is 150, the output is 150. If a student guesses 200, they are 100 off. If a student guesses 50, they're 250, they're 50 off. If a student guesses 300, they're 0 off. If a student guesses 350, they're 50 off. If a student guesses 400, they're 100 off. 450 was 150, 500 was 200, 550 was 250. So those were all the values from the table. It asks what is an appropriate domain and range for this model. So the first thing to think is the domain is asking all of the possible x values, and the possible x values we could have, is there a lowest possible guess somebody could make? Well, it doesn't make any sense at all that somebody could guess that there are negative Jolly Ranchers, because that doesn't make any sense. A student could maybe guess that there's 0 Jolly Ranchers in there if they think like I'm playing a trick on them or something. So I would say that 0 is the lowest possible guess. And there isn't really a highest possible guess. Maybe a student thinks that Jolly Ranchers are really small and there's like 2,000 in there. I don't know. Maybe students are bad at guessing. This is what could students guess. So the domain, it doesn't make sense that there could be in-between values. And so I'm going to use a discrete domain. In a discrete domain, you just list each of the possible values, and you do it in braces. So the smallest domain value we could have is 0. The next smallest domain value we could have is 1. This means a student could guess 0 or 1 or 2 or 3, and there is no highest domain value, so we can say ... It keeps going. We don't have to put an infinity there. I'm choosing to. The range, we're saying what are all the possible values for how far off a student could be. Well, if a student guesses it exactly correctly, they're 0 off. It's not possible for a student to be less than 0 off. A student could be 1 off or 2 off or 3 off depending on what they guess. Like if a student guesses 301, they're 1 off. If they guess 302, they're 2 off. Is there a maximum they could be off? Well, no, not really. If they guess 5 million, they're going to be off by a lot. So, again, I'm going to use a discrete domain, and the reason I am doing this is because it doesn't make any sense to me that a student might guess 0.5 Jolly Ranchers. Maybe they could, and if you want to make an argument that a student could guess 4.7 Jolly Ranchers and that all the in-between values are there, then you could use a domain like this, where you're saying any number between 0 and infinity is allowed. I think this doesn't make quite as much sense because a number like 0.7 doesn't make sense that it would be a reasonable guess for a student to make. And so I'm not going to use this, which would say that all of the numbers between 0 and infinity work, and I'm going to use this one, which says only the whole numbers between 0 and infinity work. So that is my domain.